Okay, this is take two. I uploaded a video this morning where I went through the 2023 practice paper. I thought everything was going well, but obviously I'm not looking at the video recording as I'm writing and thinking. And somebody pointed out that I moved the paper a couple of times and it meant that viewers couldn't read the questions that I was answering. So here's the second attempt. Same as previous, 80 marks, 90-minute paper, which means there's 1 minute per mark, or 1 mark per minute, depending on which way round you want to look at it, with 10 minutes at the end to review your answers. Of course, it doesn't always work out like that. Some of the questions are very, very quick and simple to answer, so you'll gain time there. Some of them take a little bit more thinking, a little bit more time. Anyway, I want to try and make this shorter than this morning's upload, so let's crack on and work our way through this paper as quickly as we can. If you didn't hear what I said in a previous video, OCR released this as a follow-up to a lot of the criticism and comments that they had from the 2023 official paper 2, which was deemed too difficult, had too much variation in terms of format compared to previous papers and past papers and practice papers and specimen papers and so on. So they released this to give teachers and students, most importantly, the chance to practice some paper 2 programming and algorithm questions before the real exam. Now, I've just printed this myself, which is why it's not in a booklet format. I don't have the ability to print a booklet format at home, I'm afraid. Okay, section A. We advise you to spend approximately 50 minutes on section A, and these are usually theoretical type questions about algorithms and programming, okay? So there's very little algorithm type questions in section A. There may be like search algorithms, sort algorithms, but you'll see those as we come across them. Question 1, tick one box in each row to identify if each operator is a comparison operator or an arithmetic operator. So a comparison operator is where you would look at if something was the same as something else, if something was greater than something else, or if something was smaller than something else. Whereas arithmetic is an operator that we would use to perform simple mathematical tasks. So the obvious one, of course, is the addition, which is arithmetic. So I'm going to tick that straight away to get that out of the way. And I think also the first one is quite obvious as well. 2 equal signs means is equal to. So I'm going to tick the comparison box. Okay. We've then got div. Now, div is a type of division which returns, like as the result, the integer part of any division. Okay, so it returns the integer part of any division. I'll give you an example. If you did 7 div 2, so 7 div 2, that would return the number 3. And the reason for that is because if you do the division in your head, the simple standard mathematical division, you might think the answer is 3.5, which is correct in mathematical terms. But 7 div 2, div is a different operator. It's not concerned with any fractional, decimal, remainder part of any division sum. So 7 div 2 will give us the integer part of any division. In this case, it will give us 3. Okay. Now, if I look at it the flip side, I could say 7 mod 2. Now, mod would return the remainder part only. So 7 mod 2 would return 1. Because 7 divided by 2 is 3, remainder 1. Okay, so it returns the remainder part. So in this case, it would be 1. Anyway, mod is not part of the question, it's div that we're looking for. So div, therefore, is an arithmetic operator. And then we've got this greater than sign, and I personally believe that Ronaldo is greater than Messi, although I do realise that's slightly weakened by Messi's recent World Cup win. But greater than is a comparison operator. Let's not worry about football for now. 4 marks. Thank you very much. Nice, relatively easy start to this paper. Okay, the second question, which I've kind of graffitied over now with my working out and examples. Give the output of each algorithm. Temp equals 7. If temp is less than 10, then print temp. Is 7 less than 10? Yes, it is. Okay, print temp. Now the answer to this is not temp in speech marks, because temp here has no speech marks around it, so it's not a string. Temp instead is the value of the variable, and the value of the variable is 7. Okay? Value equals 3. Value equals value minus 1, so 3 minus 1 is 2. Print value times 2, so print 2 times 2, 4. Don't overthink it. Get it down, move on. And scores equals 3, 6, 6, 9, 2, 8. This is a list. Okay, so we've got a list. Number equals scores, square brackets 2. Now what this refers to is the position of a value in a list. Okay, and 2 is actually the third number because we start lists at 0 with an index. So 0, 1, 2, 3, 4, 5, 6. They've actually been quite nice to us here because even if you put the index starting at 1, the answer would still be the same because there's 2 6s next to each other. But anyway, that's incorrect. So I'm going to put a line through that. And the value found at position 2 is 6. So 6 is my answer. 1, 2, 3, 7 marks. And what are we, 2 minutes in? 3 minutes in? So we've saved a little bit of time there. Okay, so day equals Monday in speech marks. That means it's a message or a string variable. X equals day dot length. So we're looking at day, Monday, dot length. How many characters are there in Monday? Well, there's 0, 1, 2, except we're not starting at 0. We're going 1, 2, 3, 4, 5, 6. Print X. X equals day dot length. The length of Monday is 6. That's my answer. Okay. Now we've got an array question, which says, an array stores a collection of words and the array has the identifier, that just means name. Don't overthink it, it just means name. Data. So again, I'm going to do the same thing here. We've got the 0, 1, 2, 3, 4, 5, 6, 7 positions. A searching algorithm is used. Searching algorithm, that's important. Why is it important? Well, there's only 2 types of search algorithm, isn't there? There's a linear search and there's a binary search. Now, a binary search requires a list to be in order. So, for example, if they were numbers, it would be 1, 2, 3, 4, 5, 6, 7, 8. And then you could use a binary search. Any list that's not ordered or unordered, we have to use a linear search with. Okay? So just looking at this data, and is after or. Now, alphabetically, and should be before or. So, in fact, without even reading the question, I know that this is going to be about a linear search. State the name of this searching algorithm, linear search. Now, I could do a longer explanation as to how the code explains what this is, but we don't need to because the list is not in order, so therefore it has to be a linear search. Game over. Okay, trying to get through this as quickly as possible to spend time on the harder questions towards the end. I just need to keep checking that I've got the paper in shot. There we go. Some words appear in the array more than once. Refine the algorithm to count the number of times that a word appears in the array and then output this number. This is not too difficult because you can use the code that was on the previous page as a starting point. Okay, now I've got another copy of the exam here. I'm just going to refer to this on my right hand side. This is the one that I messed up earlier. So I'm going to write pretty much the same beginning to the code as the example on the previous page. Word equals input, enter word to find. Okay. Now we're going to count how many times this word appears. So what's always a good idea is if you've got a variable like count, establish it and set its value or initialize its value to 0, because obviously we haven't found any yet, so count is going to be 0 automatically. And what we'll do in a minute is we'll use an increment piece of code which will add 1 to it each time. My example in another video was that your birthday is, or your age, sorry, is a great example of incrementation, because on your birthday every year your age goes up by exactly 1. Okay. We need to use a loop because we're counting how many times a word appears in the array, and we're going to do it over and over again. So If you remember, I put an index above in the array of the previous question. It was 0 to 7, which means there are 8 values in that list in total. So I'm going to use a loop that will iterate 8 times. So I'm going to say for I equals 0 to 7. Okay, this is not Python, so I can write 0 to 7. If this was Python, 7 would actually be the terminating number, so I'd need to put 0 to 8. But this is not Python, this is an algorithm. I can put 0 to 7, and the examiner will understand what I intend. I've got a ruler here, because when on paper 2, I find it useful to show the marker, or the assessor, your indentation structure very clearly, okay? Now, for I equals 0 to 7, usually in Python there will be a colon there. So my next line is going to be indented. And what we're going to do is we're going to say if data square brackets I. Now what this I is doing is it's the I which counts which step of the loop we're on. But also what it'll do is it'll be a placeholder for each word that we check in the previous array. So when we're on the 0th loop, the first loop, it will check the 0th value, the first value. When we're on the second loop, it will check the second value. When we're on the 4th loop, it will check the 4th value, and so on. So that's why we use if data square brackets I. It's checking the position of one value in an array. Sorry, it's checking the value of one position in the array. So if data I equals, that means is the same as or is equal to word, the word that we're searching for, okay, then I'm not putting a colon because I'm not doing it in Python code. Count, we're going to say count equals count plus 1. Now I know there's different ways of doing this, but I'm going to keep it simple. You can do count plus plus in some languages, and you can also do count plus equals 1. I prefer the other methods, but I think this is easier to explain and easier to implement and remember. Okay. And then all we need to do, because we've counted the number of times it appears now, we just need to print it. So we go back to our sort of default level of no indentation, and we say print count. Now, if you really want to, you can rub out those lines that you've just drawn, but I don't think it makes a massive difference. I think the examiner would almost appreciate that you're making your intention when it comes to indentation absolutely clear. So 4 marks, I think we've got all 4 of them. Let's move on. We've got section A and section B, right. So this is about an insertion sort. Now an insertion sort, if you remember how it works, I'm just going to try and be really quick with this. 1, 2, 3, 4, 5, 7, 6. Okay, 1, 2, 3, 4, 5, 7, 6. No, I'm not having a bit of a meltdown. If I draw a line under 1, 2, 3, 4, 5, what that does is that indicates that 1, 2, 3, 4, 5 have already been sorted. And what I'm going to do now is I'm going to check with number 7. So I'm almost going to lift this out to check where it belongs. Does it belong here? No, 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 no. It's greater than all of those numbers. So I'm actually just going to put it back where I got it from. It's going to stay there for now, and I'll put a line underneath it to say that I've sorted it. And then with number 6, I'm going to lift number 6 out of the list, and I'm going to check it against all these other numbers. So it's bigger than, bigger than, bigger than, bigger than, bigger than, smaller than. So I'm going to drop 6 in here, which would obviously change my list. 6 can go there, and then I'm going to rewrite my list. 1, 2, 3, 4, 5, 6, 7. Underline it. That's now entirely sorted. So the reason I did that is to show what's going on here, and 3 ands in a row, it or when. This is in alphabetical order, so section A has already been sorted. Section B with or before it has not yet been sorted. Okay. So section B is not yet sorted. And the question, funny enough, explain why the array is shown with 2 sections. I'm going to say section A is the already sorted sublist. That means like part of a list, whereas B is yet to be sorted. Thank you very much. Describe the steps an insertion sort takes to complete sorting the array data. This is the array data, the whole thing. So what we're going to do is we're going to take OR first, because OR has not yet been sorted. So we're going to say compare OR with what's to the left of OR, when. Okay, compare OR with when. OR is alphabetically less than when. So swap them. Okay, so swap OR and when. So OR is going to go there and when will shift to the right. Now OR, if we compare it with OR again, it doesn't need to move again. So I'm going to leave that there. Now I'm going to say repeat this process with it and when. And I think that's enough to get all of the marks, because we've shown very clearly that we understand how it works in our first response. Okay, and then we've said repeat it. And obviously with an algorithm, if we can make it more efficient, we should try to do that. This isn't an algorithm, it's a description of how it works. But I've said compare OR with when, that would be the first mark. OR is less than when, so swap them, that would be the second mark. And repeat this process with it and when. I think that's all 3 marks. Okay, one sorting algorithm splits an array into single items and then combines them into an ordered array. Can you state the name of this algorithm? Yes, I can, but can you? So what they're describing is an array that has to separate the numbers into individual values first, and that is a merge sort. Okay, merge sort. Let's turn the page. This is slightly annoying that they're printed on single pages, but like I said, I didn't have the facility at home to print as a booklet. Complete the description of computational thinking using the given list of terms, and not all terms will be used. Computational thinking is the process of analysing problems so that they can be solved in a logical way. The process of something breaks down a problem into smaller, more manageable parts. The example I always use when I'm teaching this, when you are, when somebody has passed away and you're laying them to rest, we usually bury them in the ground and their body will gradually decompose or break down. The question is looking for something that breaks down, and I just said the word decompose. And one of the options we've got here is decomposition. So it's the process of decomposition which breaks down a problem into smaller, more manageable parts. We've then got the process of something removes unnecessary detail from the problem so that the main components can be focused on. This is what we call in computer science abstraction. Okay, abstraction. Now, the next one, I'm about to be slightly embarrassed again, because the other day I forgot this term while doing one of these papers. It wasn't a question, I was talking about the 3 computational, the 3 components of computational thinking, and I forgot algorithmic thinking. So there we go. Algorithmic thinking identifies the main steps needed. I did put it as a comment in my video comments afterwards, but yeah, I had a brain fart the other night. Identifies the main steps needed to solve the problem and the something that the steps are completed. Order, is there a word order? Algorithm, computation, no. But there is a word that's similar to order, which is sequence. So I'm going to say that sequence must be the correct answer. Okay, another 4 marks, I believe. Thank you. A programmer uses a high-level language and an IDE, an integrated development environment, to create a computer game. Describe 2 advantages to the programmer of using a high-level language instead of a low-level language. Okay, high-level languages, I'm just going to put HLL, are the human-friendly languages. They're written in a language which is a way that's very similar to the way we use our own language. And low-level languages are things like binary and machine code and assembly code, which are more similar to what the computer wants. Okay? So if you compare adults and babies, adults usually eat solid food that they can chew with their teeth. You think of that as high-level language. Babies can usually only drink milk because they don't have developed teeth at all yet. So low-level language is similar to baby milk. High-level language similar to adult solid food. Okay? Adults prefer solid food, babies prefer milk. Yeah, weird analogy, but hopefully it makes sense to some of you. Describe 2 advantages. So human-friendly language, let's say written in a language or style more similar, because we can't say it's the same, we can say it's more similar to that of a human's everyday language or vocabulary. Using English or English keywords. For example, print. Print makes sense. Okay, what's another advantage to a human of using a high-level language? Well, this is probably something that I wouldn't expect all students to answer. But a high-level language is what we call abstracted from computer architecture. So the abstraction removes the requirement for a programmer to understand CPU/RAM architecture. Now that's quite a difficult second part to that question. I would say that most students are going to get 2 marks of 4 there. Only probably the top 10-20% of students would get the second one, in my opinion. That's a difficult two advantages type question. If it was just one advantage, I think everybody would say the first one. Okay, the IDE includes a translator such as a compiler or an interpreter. Tick 1 box in each row to identify whether each statement describes the use of a compiler, an interpreter, or both. Now, what a compiler does is a compiler puts all of your code together into one file when the code is completed and when it's free of error. Okay, so a compiler does it basically builds all of the code all at once into something called a .exe file, which your network technicians at school will not like you using. They're probably blocked because they can potentially be quite harmful if you know what you're doing. So a .exe file is what a compiler will produce. It's also known as an executable file. So let's put a tick in compiler there. Translates high-level code to low-level instructions. Well, compilers and interpreters both do that. So I'm going to tick the both box. And just looking at the options now, program needs to be translated each time it's run. That is an interpreter, similar to what we use with our Python IDE. Okay, so 3 marks there. Lovely. We've got a Boolean logic question, one of my favourite topics because it's so logical and simple. Just like me, I'm simple and logical 99% of the time. A computer game uses a controller with 3 inputs, A, B and C. So a bit like the old Mega Drive controller, if you know what I'm referring to. An action P is carried out if the player presses A with either B or C at the same time. So this is B or C in brackets and A. That's how I interpret this, B or C and A. Now, because B or C is in brackets, we do that first. So let's have our inputs joining together with a curved back, pointed front OR gate. It looks a bit like a rounded triangle. I'm going to put or in there just so the marker knows what I'm doing. And we've got an AND gate coming to meet its output up here. It looks like a big capital D. And that output will go to P. For 3 marks, that is pretty generous from the exam board there. That's pretty easy. So 3 marks for that one. Complete the truth table for P equals not A or B and C. This is slightly tricky, but I'm going to show you how I would go about it. Again, just trying to be as logical as possible. So P equals not A or B and C. Okay. Now you can't necessarily take highlighters and stuff like that into the exam as far as I'm aware. So we're going to have to be a bit creative with this. Let's start by trying to complete this first block up here because we've got all the information we need to do so. So P equals not A or B and C. What I'm going to do, using a different colour, I'm going to flip A because that's what not A does. So they're all zeros, I'm going to turn them into ones, and I'm deliberately doing it in red because I believe the markers mark whatever you write in black. So 1, 1, 1, 1 is the opposite or not of A. And then what we're doing is we're using B and C. So B and C means that a 1 would be produced if both B and C are both 1. So this would not produce a 1, this would not produce a 1, this would not produce a 1, but this would. So I'm going to put a 1 there. Now actually what I just did doesn't matter, and the reason it doesn't matter is because the statement says not A or B and C. Well look, not A is 1 in every instance. So an OR gate only requires 1 positive input to produce a positive output. So regardless, all of these 4 would all be 1. Okay, all of those 4 would all be 1. Right, I'm just going to box that because I believe, and I think I remember because I've marked some students' attempts at these questions before, I believe the mark scheme awards 1 mark for getting all 4 of those correct. So I'm going to box those. Now we've got this bit at the bottom that we've kind of got to play around with a little bit and figure out how we fill in these gaps here. Well, I'll show you how we fill in these gaps here. 0 plus 0 plus 0 in binary is 0. 0 plus 0 plus 1 in binary is 1. 0 plus 1 plus 0 in binary is 2. 0, 1, 1 is 3 in binary. So I think it would make sense to assume that this is going to be 4, 5, 6, 7. Okay. And in this case, if you imagine that the placeholder values for C are 1, B are 2, and A are 4, like we're counting in binary, 0, 0, 1 is going to be 4. 1, 0, 1 is going to be 5. 0, 1, 1 is going to be 6. 1, 1, 1 is going to be 7. So I believe that the answer to that empty area there is the same as our first answer, all ones. So now we just need to work out the outputs. Some of you probably didn't have a clue where to go with that one, but hopefully that makes sense. So we've now got 1, 0, 0. I'm going to do the same thing I did in the previous part, and I'm going to flip A first. So 0, 0, 0, 0. It's not A or B and C, remember. So what we're looking for now, because these are all 0, these would all be 0 unless any of these produce a positive output of 1. And we're working with B and C, so both of them would need to be 1. Well, these are both 0, so that's going to be 0. 0 and 1 going through an AND gate would produce a 0. 1 and 0 through an AND gate would produce a 0. 1 and 1 through an AND gate would produce a 1. So I believe that the only row which will be a positive output will be this one. All the others will be zeros. And again, just for the benefit of the marker, just to make sure that they don't get distracted by all of my methods and stuff, I'm going to put a box around my answer. You don't have to do that, but it's a good idea to do so if you want to make it clear what is your actual answer. Okay, in the computer game, a player collects items. Each item has a score. The score for each item is stored using the data type real. State what is meant by the data type real. Real is a decimal value, a decimal data type. Okay, so I'm going to put number with a decimal value or part. You could also say fractional as well. The result of the game could be a win, a loss or a draw. The result is stored in a variable with the identifier result. State why result cannot be stored using Boolean. This is easy. Boolean is a true/false data type. It can also be yes, no. So I'm going to say with only two possible values. So Boolean would be fine for like win or lose, but because it's win, lose or draw, so I'm going to put win, lose, draw requires 3 options. Okay, so it wouldn't be a suitable data type because it's a true or false data type. There's only 2 options. Win, lose or draw is 3. Give a suitable data type for result. Now, there's 2 ways you could do this. You could say that lose would be 0, draw would be 1, and win would be 2. That's how they used to give points in the football league tables up until about 1978, I believe. 0, 1, 2, when they changed to 3 points for a win. It might have been the 80s, actually. Or, if you put speech marks around lose, speech marks around draw, or speech marks around win, then they'd be a string. So you've either got integers or strings. And it doesn't matter what you put, so long as you explain why you've put what you put. Okay, so I'm going to put string, because to me that makes more sense. And I'm going to put win, lose, with speech marks around it, draw, with speech marks around it, are all string values. Okay, 2 marks. We're not on section B yet, so you'll notice that the questions aren't too taxing just yet, because we're not on section B. This is probably the most difficult part of section A though, the algorithm questions. So, a player enters a code at the beginning of a game, and the code is 3 characters long. The code helps to set the level of the game, and the game has 3 levels. A variable level is assigned a value based on the code that's entered. Write an algorithm that will ask the user to enter a 3-character code. Repeat the process step if the code is not 3 characters long. Sorry, repeat the previous step, I didn't say that correctly. If the code is not 3 characters long. If the code entered is SVA, then give it the value 2 to the variable level. If the code entered is UTV, give the value 3 to level. And assign the value 1 to level if any other character. Okay, this is actually quite nice. This isn't bad at all, but I'm going to reach for my ruler straight away, and I'm going to do what I did in a previous algorithm question and just draw a couple of lines vertically so that I can set myself up for any indentation. So, where should we start? So we need a variable called level. Let's start with that, and let's say level to begin with equals 0. Okay, level equals 0 to begin with. And then I'm going to say while code, because it says the length of the code has to be 3 characters long. So I'm going to use the length function. Okay, so while code dot length, I need to make that dot more obvious. While code dot length is not equal to 3, then. Okay, so if they enter a code that's not 3, then what am I going to do? I'm going to ask them code equals input. I'm going to ask them to enter their code again. So brackets, speech marks, enter 3-character code. Apologies if you can hear the television behind me. Now, because this won't run without having a code already done, or at least a value in code, I'm just going to start with code equals, in fact, let's just repeat it. Let's just say input, brackets, speech marks, enter 3-character code. I was going to do it another way, but I think that's the easiest to understand. Okay, so we've done this bit. We've asked them to enter a 3-character code and we've used the length. So we've done the first 2 bullet points. We've definitely got 2 marks. If the code entered is SVA, give level, the variable level, the value 2. This is easy. So I'm going to say while code, yep, that's okay. So this needs to remain part of the indent. So I'm going to say if code equals speech marks SVA capitals, then next line is going to be indented, level equals 2. You could say level equals level plus 2, but that could get confusing. So I'm just going to say level equals 2. Okay, keep it simple. Else, if code equals UTV speech marks, then level equals 3 is what it says in the question. So we've done that one and we've done that one. Else, there's no other option. Level equals, oh, sorry, I put 3 by mistake. I wasn't concentrating. Level equals 1. And I believe that's it. It doesn't tell us that we need to print anything. It doesn't say it's a function, so we don't need to return anything. I think that's everything. So we've done that. I believe we should have 6 marks. Okay, you might just want to say, I don't know, return, but you don't need to. You don't need to, so I'm not going to. Okay. Still on section A? We've got to write a function now. Okay, so when a player completes a level, they move to the next level. Once level 3 is completed, the game starts again at level 1. Write a function called next level that takes the current level as a parameter. This is relatively easy to do, so I'm just going to put function. They've told us the name of the level, the name of the function is next level. So next level, brackets, and it takes the current level as a parameter. So I'm going to put current level as a parameter inside the brackets. So I've done that. Now it needs to work out the integer value of the next level that the player moves to. So let's say if current level equals 3, then we need to return the number 1 so that they go back to level 1. Otherwise, else, return current level plus 1. Only 3 marks, so I think that will be sufficient. Complete the line of code to output the value returned from the function next level when the integer value 3 is passed in as a parameter. So we've got some brackets here, so straight away 3 is going to go there, and the name of the function is next level, so we're going to print next level. Oh my goodness, how easy was that? Sorry, very easy. Here we go. Now it should get more difficult. Section B. They advise that you spend approximately 40 minutes on this section. I did it this morning in under 30, so let's try and do it in 25 this time. OCR drones fly goods around the country using drones. Details about the drones that the pilots fly are stored in a database table called table drone or TBL drone. Some of the data stored in the table is shown below. Complete the SQL statement to display drone ID and mileage for all octocopter type drones that have a mileage of greater than 50,000, which this one would be. Now, all SQL statements, hopefully your teacher has told you this, start, select, that's the first keyword. The middle keyword is from, and the final keyword, which starts the conditional statement, is where. So they all go select from where every time. Select, we've got a gap here, so let's just put from, because that's the easiest win that we've got. Where is already done. Select. Now we need to look at the question for this. Complete the SQL statement to display drone ID and mileage. Please do not answer this question by putting drone ID and then the word and. In SQL, we use a comma to represent when we want more than one value from our select statement. So that's the correct way to do this. If you put and, I believe you will drop the mark there. I don't have the mark scheme in front of me, but I'm 99% sure that you won't get the mark. So drone ID, comma, mileage, will select drone ID and mileage from table drone, where drone type equals octocopter, so they've already done that bit for us, something, mileage, something. Well, the mileage is greater than 50,000 miles. So let's say mileage greater 50,000, 4 zeros. Where drone type equals octocopter, something, mileage, well, it's and, isn't it? Because both of those things have to be true. They have to be, it has to be the octocopter type, and it has to be the mileage greater than 50,000. So I think we've got a 4 out of 4 on our first question of section B. Okay, flowchart. Except we don't have to draw this one, we just have to fill in the gaps. Drones must be checked every 10,000 miles. If the difference between mileage and last check is greater than 10,000, then the drone needs to be checked. A flowchart shows the steps needed to check a drone. The flowchart outputs check if the drone needs to be checked. It outputs no check if the drone does not need to be checked. Okay, so we've got some inputs here where it's getting the data for us. We just need to do the logical decision. And the decision is if mileage minus last check. So if mileage minus, I'm going to put last check here, I know it goes outside of the shape, is greater than 10,000. So if mileage is minus last check is greater than 10,000, if the answer to that's true, then we're going to output check. If the answer to that is false, we're going to output no check. 2 marks. Thank you very much. There's got to be something harder waiting around the corner for us. No, it's a trace table. These aren't that difficult in my opinion. Now, this was one of the questions you couldn't see earlier, so I'm sorry. I'm just going to quickly stand up and check that, yep, you can see everything here. That's good. Okay. So, a pilot code is automatically generated when a new pilot joins the company. This algorithm generates a code for each pilot. A equals input, enter the first letter of the first name. B equals input, enter the first letter of the second name. C is a random number from 1 to 100. While C is less than 100, C is given the value C multiplied by 10. And then when C is no longer less than 100, you can end the while loop. So I'm just going to put a little bit of a box around those statements because I've got a feeling that's going to be an important part of this question. Let's just put a little box around that. Okay, that's a loop. Pilot code equals A plus B plus str C. That's where we turn C into a string, so that's called casting. Let's just make a note. And then print pilot code is on line 8. Okay. The table's already been partly filled in for us. So line number 1, A equals input, enter the first letter of the first name. And in column A, they've put the capital H. So I'm guessing this pilot's name is either Harry, Henrietta, or something like that. Line 2, input the first letter of the second name, so K. Okay, so let's say this pilot's name is Harry Knight or Henrietta Knight, because it begins with a K. 3 is 9. I nearly said G then, but it's a 9, isn't it? Because it's a random number from 1 to 100. Okay, so we're now on line 4 then, which is the while loop, while C is less than 100. Well, if we go back a line to line 3, C is less than 100. So let's put 04 here, while C is less than 100. Well, we're not doing anything with C, so let's not change it. Let's keep it as 9. And let's check line 5 now. So because C is less than 100, we execute line 5, which is C equals C times 10. So if I put 05 in the line number, C equals C multiplied by 10. Well, 9 times 10 is 90. That's the only thing we need to do here. Line 6, can we end our while loop? Well, it's conditional on C being less than 100. C is 90, which is still less than 100. So we're going to need to repeat line 5 one more time. Okay, so line 5 previously was G was changed to 90. Let's do it one more time, except we're going to increase it by multiplying it by 10 again. And C will now be 900. Which means that now, line 6, we can end the while loop and move on to line 7. This is where we combine the value of A with the value with B with the value of C, but C is turned into a string so we can merge them together. So pilot code, line 7, is A, which is H, capital H, B, which is capital K, and then C, which is the number 900, but we're turning it into a string to join it together. So HK 900. And then line 8, the final line, is just print the pilot code. Okay, that doesn't mean print the word pilot code. It means print the value in pilot code, which is HK 900. So I'm just going to write that down here. And that is a relatively nice, easy, logical 4 marks. If you're asking my opinion, which probably nobody did. But here you are watching the video anyway. Okay. A pilot's flying experience is validated. An algorithm checks that the experience is between 0 and 20 years. And we've got an algorithm here. Complete this test plan for the algorithm. Experience in years, type of test, and expected output. Now, the first test in the first row is normal. So what we're looking for is data that fits within the normal parameters. And it says here, if experience is greater than or equal to 0, so 0 would be okay. And if experience is less than or equal to 20, so 20 would be okay. We can use any number between 0 and 20. And I like the number 7, so I'm going to put the number 7. That's a normal test, and we would expect the output to be true. Okay. We've then got boundary testing. Now, boundary testing is where we're testing with values that are the lower limit and the upper limit of our data, our expected data. So 20 is boundary testing, and 20 should be accepted. So it should be expected output true. And finally, we've got the number 32, which, although it's my favourite number, shouldn't be included within this test plan, or shouldn't be accepted, I should say, when this test plan is followed, because 32 is outside of the bounds of the acceptable data. So the answer you can put here is either invalid, because it's invalid data, or erroneous. Error with, erroneous. Error, you change the last R to N-E-O-U-S. And the answer to that, the output should be false. Okay? I think they're relatively straightforward, those questions. It's very rare that students get less than half marks on those questions. They're still on this pilot drone question. God, they're getting the money's worth, aren't they? Pilots are paid a set amount each day. Pilots get an additional payment for each mile they fly that day, and the payments are shown in the table. For example, a pilot with 3 years experience who flies 100 miles in one day will receive £215. That's because they get £150 for the day, and then 65p per mile times 100, so an extra £65. Okay, we've got to write an algorithm, or complete an algorithm, that calculates their total pay for the day. This shouldn't be too difficult, because it's already kind of started for us, which means we can follow some of the instructions that are already here. Okay, so experience, so we've got the input, miles, we've got the miles, and we've got total pay established or initialized as 0. Let's say if experience is less than 2, because what I'm looking at is fewer than 2 up here. So if experience is less than 2, then total pay, I'm going to do a big indent just to make it absolutely obvious. Total pay equals 120. Yeah, they get that as a base rate, plus their miles for the day that they've flown, multiplied by 45p per mile, so multiplied by 0.45. Now, it's important that we put brackets around the mileage calculation, because that should be done first and then added to the fixed flat rate of 120. Okay. So now we're going to use else if. Else if experience. Now, because we did less than 2 first, I'm going to say less than or equal to 5. So less than or equal to 5. Then Same as before, total pay equals, except it's not 120 this time, it's 150. Plus brackets, we're going to follow the same format, miles multiplied by 65 pence, so 0.65. Okay. And then we've got no other options, so just else is required here. And we're going to say total pay. What does the experienced pilot get? 180 flat rate plus miles at 85 pence per mile. Okay. Now it doesn't say that we need to do print total pay. In fact, look, I've just spotted it at the bottom there. So I believe that's us done. I think on the previous example I wrote print total pay. I've just realised it's already there. We didn't need to. Okay, the programmer decides to make a function to calculate the total pay. They're still on this question. The total pay for the pilot. The function is called calculate pay. You're screwed if you don't like drones on this practice paper. The function takes the values for experience and miles as two parameters and returns the total pay for the pilot. Refine the algorithm to use this function and output the pay for the pilot. And you must use OCR reference language or a high-level language that you've studied. So for me, this is going to be Python style. But to be honest, it doesn't actually matter. I don't know why they've put that. That's so stupid, because all you've got to do is fill in the gaps. So the gaps are going to be print total pay. Now I can't see total pay up here anywhere. So it's quite clear that we're going to be the ones that work out what total pay is. So it has to be total pay, just common sense. And in the question it said the values experience and miles are going to be the two parameters. Experience and miles. Guys, if you drop any marks on a question like this, you need to have a really long look in the mirror. That is so easy. Didn't matter how you did the answer, because it's literally 3 empty boxes. I'm not sure why they said you must use that. I'm going to guess the next question might be a programming one. Oh, algorithm. Okay, so it doesn't have to be in Python or pseudocode, which actually makes our job a lot easier. Now, in last year's 2023 paper 2, I did predict one thing to my class, and I said file handling hasn't come up for a long time, several years. I wouldn't be surprised if file handling is in your paper this year. Half of the class listened to me, half the class disregarded what I said, and there we go. File handling came up in the paper. Now, this is a practice paper, so this is another opportunity to exhibit our file handling skills. I'd say it's a 50-50 chance whether it comes up this year, so I'm not making any bold predictions. I'm sitting bang on the fence with that. Okay. So design an algorithm to ask the user to input a pilot code and a date of birth. Write these inputs to the pilots.txt text file. Okay, so it tells us that the text file is called pilots.txt, so we're going to have to use that in a minute. We can't make up our own one. I'm going to start by taking the pilot's data. Okay, so I'm going to say pilot code equals input. And what's the other thing we need? The date of birth. So I'm going to say date of birth. I could have just put DOB there, couldn't I? Equals input. And then let's put a suitable output question to explain what we want them to input. So enter pilot code and enter date of birth. Okay, so ask the user to input a pilot code and date of birth. Done. Write these inputs to the pilots.txt text file. Now, you can't write to a text file without opening it first. So the reason I left a line up here is so that I could say we're going to open a text file. So I'm going to put open brackets pilots.txt, it's told us it's called. And what you need to do is you need to establish a variable here, which I'm going to call drone pilot equals. And the reason that we establish this variable here is because that's going to store temporarily the data that we're going to eventually write to our text file. Okay, so a bit further down, I'm going to say drone pilot dot right line with a capital L, brackets, and here is where we're going to use these two variables, so number 1 and number 2. So pilot code, comma, date of birth, and they're going to be our parameters that we're going to write to our text file. And when you write to a text file, it will only save it if you close the text file at the end. So really important, this drone pilot, that's the variable that holds the value for the file's name, close. Now, if you didn't know how to answer this question, I'm going to say that's rubbish, because you know how to do inputs. So you could have just done that bit and got 1 mark. And if you remember that you have to close a text file, then you can guarantee yourself another mark. But I'm quite confident we've got all 4 there. Okay. Moving on. Oh my goodness. A pilot is allowed to fly a maximum of 9 hours per day. The pilot code and the hours flown for each flight in one day are stored in a 2D array of strings with the identifier, the name, journeys. The value of journeys 3, 1, so that's 3 down this way and then 1 across this way. So 3 and then 1 would be 3.5. Create a function called pilot valid that takes a pilot code as a parameter. So that's easy because that's just going to be brackets pilot code. Okay. Uses the 2-dimensional array journeys to calculate the number of hours that the pilot has flown. Returns valid if the pilot has flown 9 hours or fewer, or warning if the pilot has flown for more than 9 hours. And it needs to use casting where needed. So casting is where you do str, int. You can also do float as well. Okay. You must use either OCR exam reference language or a high-level programming language. Okay, so me and my class, we use Python. So I'm going to write this in a Python format. This is the final question, by the way, on the paper, and it's a 6 marker. It just says so on the next page. Okay, so in Python, we would say def to define the creation of a new function. And then the name of the function, which in the question it says is called pilot valid. And sorry, I've left a bit of a gap there, but that'll be brackets pilot code. I'm not going to change that. So def pilot valid, brackets pilot code. Okay. And in Python, you would put a colon after the parameter. Inside that's going to be indented. So I'm going to start by initializing a variable as total equals 0. And we're going to use a loop. Why are we going to use a loop? Well, because it has to check every value in this list, and there's 6 values. So I'm going to use a loop that says for I in range, because we're writing this as Python code, for I in range, brackets 0, 5, close brackets, colon, indent my next line. If, this is the hard bit, if journeys, now I'm putting if journeys because the question says uses the 2D array journeys to calculate the number of hours that the pilot has flown. Now this is the hard bit because you're going to say if journeys square brackets, but I don't know what I'm going to put in there yet. I'm going to decide in just a second, equals something. Okay, and I'm going to explain what I'm doing here. In the example they give you, the value of journeys square brackets 3, 1 is 3.5. That's because you're checking the third, or in this case, the 4th value in the 0th column and in the first column. Okay, so the pilot code is there, the number of hours there, 3.5. So what we're going to do is we're going to use the index counter or the loop counter I to replace the first value inside our 2-dimensional array. This would actually be the value found in the 0th column. Okay. So I, 0. So if journeys I, 0, that means on the first loop, it will check this one. On the second loop, it will check this one. On the third loop, it will check this one. Fourth loop, it will check this one, and so on. So if journeys square brackets I, comma 0 is equal to pilot code. I think that's the correct way to do this. Colon. My next line is going to be indented because it's after a colon. Then we need a temporary variable to hold the value that we find. And the value we're going to find is how many hours they've flown. So that's this column here. Now, the way that we do this is by flipping the 0 and the I around. Okay, the 0 and the I get flipped around. No, they don't. Sorry, I beg your pardon. Let me just get that right. I beg your pardon. They don't get flipped around. My mistake. What we're going to do is we're going to say journeys. I've left a gap deliberately. Square brackets I, comma 1, because we're checking the other column now. But do you remember in the question it says it uses casting where needed? And that's because there's two values here that are decimal numbers. And when it's a decimal number, we want to use the casting function called float. So I'm going to put float around my journeys. Okay. That's probably confused quite a lot of you. I would normally estimate that maybe my top 10% of students would get this right and get, you know, at least 5 out of the 6 marks. This is definitely a more challenging question to use a 2D array. On the previous question, it was about file handling. 2D arrays is definitely more challenging than that. Okay, and then we need to check if the total hours flown is greater than 9, but we need to do it inside our loop. So where's my ruler? Many of you will have switched off by now, I'm sure, because you'll have just gone, nope, I'm going to get 1 or 2 marks on that question and I'm going to close the paper. If total, because that's the number of hours that we were calculating. Now, we haven't finished on the previous line, actually, just having written if total. What we need to do is say total equals total plus temp, because that's the hours they've flown. Sorry, forgot about that temporarily. So if total is greater than 9, colon, which means the next line is going to start here after the indent, then the status we give is warning, because that's what it says in the question. Speech marks. Else, status, what did it say, is valid. And then the last thing we need to do, because it's a function, we need to return the variable value, or the value of the variable status. And I think that's the 6 marks required. So I think that would do it. But what I would say, if you're a student that struggles with this, here's what you should do. Let me get a piece of paper here. It takes the pilot code as a parameter. Create a function. If you've learned Python, you should know that pilot valid, okay, pilot valid brackets, pilot code. That'll probably get you 2 marks, because you're going to get 1 mark for creating the function maybe, and 1 mark for using the right parameter. Okay, that's probably 2 marks. Just write that before you close the paper. Okay, obviously your question is not going to be about pilots, so if it's about something else, you know, put def and then the title of the function, and then the parameter. Okay, so that would be my final little tip to you, to try and get an extra 2 marks at the end on a question that maybe you're not sure about at all. Good luck on Tuesday afternoon. Please, if you've got any questions, put them in the comments. I will check and I will respond. Thank you and good luck.